Now we have Honorable Dr. Hammad Majeed with us. He is seasoned professional with more than 23 years of experience in diverse fields such as academia, industry, and entrepreneurship. He is currently serving as head of chemistry department and ORIC at University of Management and Technology Sialkot. Dr. Majeed has made significant contributions to curriculum development at various educational levels and has been a visiting faculty member at various universities in Pakistan. His expertise include industries like textile, sugar, biotechnology, with a focus on intelligent manufacturing. He has been recognized for his achievements with awards including prize from President of Pakistan. Dr. Majeed is also an active member of professional organizations and has a strong research and publication record. His dedication extends to volunteer work for sustainable development in Pakistan and collaborations with international communities. He holds the position of an official trainer of the Forestry and Agriculture Departments of Government of Punjab. I am personally very much impressed to know his profile. Sir, I am highly thankful to you for your esteemed presence and precious time. Kindly start with your lecture now.
Thank you very much for a nice introduction. Am I audible to all?
Yes, sir.
Uh, my screen is visible?
Yes, screen is visible.
Okay. So, my topic is the intelligent manufacturing techniques for industries to reduce the impact of climate change. In this talk, I will explain what is the intelligent manufacturing, what does it mean, and what is the role in industry, especially in Pakistan, and what is the role of our scientists, the chemists, the biologists in the industries, and how we can participate in the intelligent manufacturing, and how we can link this with the climate change, because Pakistan is the in vulnerable condition, and we need to work on the climate change as well. This is my profile. I did my MSc, MPhil, and PhD from University of Agriculture, Faisalabad, and I have 23 years of working experience in industries, sales, marketing, import, export, research, innovation, and now teaching. And most of the things are also introduced in the introduction by the host. And I have 50 plus publications, 6 patents, and most of the MOUs with the industries. And currently, I have international projects. Recently, I completed a project of British Council, and recently, Natural Science Foundation, China. So, what is the intelligent manufacturing? What does it mean? Intelligent manufacturing means the utilization of advanced technologies, data-driven solution to enhance the efficiency, productivity, sustainability in manufacturing process. Like for example, in industries we are making many things. In chemistry we are preparing the chemicals, but we are using the manual systems. So what is the intelligent manufacturing? That we can put all things in the automation system, that how we can produce by with the automation system, that with the help of automation it is very easy to reproduce the things. It is very easy to reduce the batch to batch variation, and to produce the same things many times without any error and other human errors. We can produce the things with 100% efficiency. And also with the help of intelligent manufacturing, we are able to produce the sustainable things. What does it mean? That when we manufacture a thing in the present, we have to take care about the future generations. Like for example, if we are producing a plastic material and we know that this is not biodegradable, it will be dangerous for our future generation, then we must not produce it. We must produce the biodegradable plastic. This is the approach of a sustainable mentality. And the climate change, we have to reduce the impact of climate change, we need to work on sustainable approaches. Similarly, United Nations have 17 SDGs, Sustainable Development Goals. We have to link these 17 goals in our research, in our academia as well. What is the climate change? It is actually, you are the science people, that this is the actually the increase in carbon material, like the gases from carbon dioxide or methane. These are the main impact of global warming, that they trap the heat from the sun and the temperature of the earth is going to increase with the burning of fossil fuels like coal, oil, and gases. These are the main three sources of fossil fuel. So we reduce the fossil fuel burning, and we have to increase the renewable energy resources in our all supply chains, in our domestic things, in our industries, in our aviation industry, and all types of working in our daily life. So what is the carbon footprint? With the global warming, when we talk about the carbon, that it means that carbon footprint, we have to reduce the carbon emission. So mostly we calculate it per annum, and it is the equivalent tons of carbon dioxide. In America, the people have the 14 tons per annum carbon footprint per person in America, which is very high. It means that the USA, China, and India are the responsible for the climate change all over the world. These actually, the 10 nations are responsible for 60% of the greenhouse gas emissions. So they are working on the reduction side. Recently, the COP28 Conference of Parties is going on in Egypt, in UAE right now. Last year, in COP27, they decided that the China and the America, they will reduce the coal burning by 50%. In COP 26, 27, and now in 28, their main focus is the reduction of the carbon footprint all over the world. And this is the approach that we can reduce the carbon footprint in our industry. What is the circular economy? It is that we have to recycle and reuse the things again and again, and there must not be the end of life of anything. By adopting the circular economy approach, it is very easy for us to reduce the carbon footprint in our supply chain. And you know the difference between linear economy. If we make a thing and after using it we put it in the dustbin, it is the linear economy that make, use, and put in the trash. But in circular economy there is no trash. And in the regular intelligent manufacturing and industrial revolution, that scientists are working that there must not be a dustbin anywhere in the world, and everything should be recycled and reproducible. This is the difference between different industrial revolutions. Industrial revolution 1 and 3, which is the past. In 1670, the people start working on the industrial revolution, and at that time, the people start making the things with the help of machines by burning the fossil fuel. At that time, the people have no idea about the climate change. The people have no idea about the global warming, and there is agriculture advancement at that time, and the people start making the agriculture products for the other nations as well, and they start exporting and importing the things, and the technology advanced, and the people start making the money by exporting and selling the things just to increase their profitability, but they are not thinking about the environment at that time. Similarly, at that time, urbanization developed, and the people moving from the rural area to the urban areas just for the sake of working and for the sake of industrial revolutions. But this is very alarming at that time. And in industrial revolution 4, which is currently working all over the world right now, but unfortunately in Pakistan we are even not adopting the industrial revolution 4. What is industrial revolution 4? This is the total intelligent manufacturing technology advancement in industrial supply chain. But for this they need 5G internet connectivity, but in Pakistan we don't have the 5G right now. But the Jazz company is working, and many other companies are working for the high speed internet in Pakistan as well. But the main points in the Industrial Revolution 4, the what type of technologies the people are using, is the automation. That everything should be human free, and everything they can use the robotics and other things. Similarly, in biological sciences, genome editing has a very high profile working in this Industrial Revolution 4, just because of the Industrial Revolution technology is usable. Similarly, in Internet of Things and additive manufacturing, 3D printing is the manufacturing of the things from with very accuracy, and by the adopting the 3D printing technology, the people are producing very tough and very complicated designs, especially in the space science and in the aviation industry. Big data analytics, most of the scientists in whether they are chemists. Yes. Most of the people in Pakistan and anywhere in the world, the science people like chemistry and biological sciences, they think that they don't need to learn the computer science or the things related to the computer and the software. But if you are unable to learn the artificial intelligence, machine learning, the cloud computing, and the supply chain traceable things, you will not survive in the new industrial revolution, because the future that we have to link everything with the internet, and we have to link everything with the artificial intelligence. So I must say to the science students that you can learn the science, basic sciences, but for advancement, you need to learn the machine learning as well. Because in the textile industry, in the steam power, transportation, aviation, iron, steel, plastic, every industry is now integrated with the latest technologies. But in industrial revolution 5, the people are thinking about the sustainability, about the climate change. Because right now in industrial revolution 4, their main focus is the generation of money with the help of these high technology advancements. But in industrial revolution 4, the people are thinking about the sustainability, about the circular economy, and we have to reduce the global warming at 1.5 degrees centigrade. What does it mean? That if the global warming is is more than 1.5, the humanity will be in danger, because up to 2100, if we are unable to reduce the global warming, there will be no human on this earth. So we need to work on the global warming as well. Race to zero mean this is also an ambition of the COP 28, 27, the people working on the climate change, that we need to overall the net emission of our supply chain must be zero. For example, if I am working in an industry and I have some carbon footprint, I have to do something to reduce the impact of climate change. That net zero is the carbon emission. For example, I have to work something to reduce the, for example, if I am working on industry, I can increase the plantation. In Pakistan, we need 540 trees per person to reduce the impact of climate change. But unfortunately, right now we have only 5 trees per person in Pakistan. We need 25% forest in Pakistan, but we have 4.5% forest in Pakistan right now. So this is a very alarming situation. We need more plantation in Pakistan. And if our carbon footprint is 2 ton per person, then we are on the safer side. So on industrial scale, they have the targets of 2030, 2050, and 2100. In 2030, in Pakistan, we have the target that 50% vehicles will be on the electric side. But right now, I don't think so that we can meet this challenge. And up to 2050, in Pakistan, we have the commitment with the world that there will be no car on the road with the fossil fuel burning. The same types of targets are set by the world in all types of countries. Why we have to work in Pakistan? Because in Pakistan, we are at the in the top 10 countries with climate change problem. So we need to work on it very seriously. In industrial revolutions, which is the future, uh, we can make digital twin. What does it mean? For example, if we are working in Pakistan and moving something, the same will happen in the USA. So this is not the technology that is very tough right now, because I recently visited China in August 2023, and I got the training on intelligent manufacturing. I saw that they are working on the digital twin and they are very successful. Everything is in, for robotics. Quantum radar control. Similarly, they are working on pico technology and femto technology, and teleportation is also is not a myth right now. Green production and mean everything should be recycled, should be sustainable. If we are being a scientist, if we are producing anything, we are working on any type of research, we need to make it sustainable. Don't prepare any material which is dangerous for humanity, which is dangerous for your environment, which is producing carbon. So we need to work on zero emission technology, and there must be zero trash in your supply chain. If you are making a thing, then design that thing in a way that, for example, if there is any fault, you can repair it easily. And don't make such type of things that we need to put in the dustbin. Similarly, we are working on electronics. E-waste is also a very alarming situation, even in Pakistan. So this is my brief introduction of the industry revolution and what type of intelligent manufacturing we need to work being a scientist. You can see that these are some products that we are using right now, sustainable and non-sustainable things. The non-sustainable things need many years to degrade. So this is not the approach in the modern world now. These are my research areas that I am working on, such circular economy, and I recently completed British Council project. I am also working with the Upsign. I recently won a National Idea Bank country level competition on sustainability. I worked on water and energy saving and in industry. Similarly, I'm working on the food security, and I'm working on the waste material as well, agriculture waste, preparing many usable material by using the waste material. So you can focus your research that how we can reduce the trash. Same type of research is necessary in Pakistan, that reduce trash, use agriculture waste, use plastic waste, and how we can convert into upcycle and valuable material. And we must not work on the fossil fuel burning material. Similarly, in coal, we can convert with the microbes, and we don't need to burn it to produce energy as well. Most of the people are working on the water splitting, and but they are not thinking about the how we can produce low cost and high efficient water splitting material. But one thing is very alarming, that hydrogen energy is also not sustainable if it is at the larger scale. So this, there is also limitation in water splitting research. Similarly, we must work on the renewable energy resources. This is not only a scope in Pakistan, but all over the world. The people are thinking, but in Pakistan we know only the solar energy as well. We are not working on the wind energy or other type of renewable energy resources. So we must work on it. Similarly, in drug discovery, most of the chemistry students know this, that molecular docking and the computational chemistry is very helpful in such type of research. But many people are still don't know about the computational chemistry and molecular docking softwares. So we must learn these softwares, which is very helpful because the world is using in drug discovery as well. Recycled batteries, many people, even your Dr. Adnan is working on the recycled batteries as well. So I think recycled batteries need to be addressed in Pakistan as well in a serious note. Antimicrobial products is the biodegradable products, and the raw material is also natural raw material. We must work on this. So these are some ideas about how we can produce science in Pakistan. Technical textile mean medical textile, and nanoscience mean many people are working that they just use the fabric. But in the modern world, the smart textile like automation in your shirt, sensor system in your t-shirt, and similarly in medical textile, the people are producing by using fibrous material and producing many body parts as well. And this is a very big area, the medical textile and other types of technical textile things. Data science, big data, intelligent manufacturing, these are all need to be addressed in Pakistan as well. I'm also writing a book on Industry Revolution 4, 5, and 6, and it will be in the market in the mid of 2024, inshallah. I am working on the robotics and artificial intelligence, and I recently got training from China on that thing, and I am trying my level best to integrate these things in our industry. I'm giving lectures in the Chamber of Commerce that how we can convert in our industries in the same system on the automation system as well. I even got these trainings in 2023 from Italy on the industrial automation. So I'm trying my level best to deliver these trainings to the industries in Pakistan. So these are the 11 R's that need to be addressed in Pakistan, that we must raise the awareness with such type of sessions, seminars and webinars. And we all know that the such type of seminars are very helpful in sharing the knowledge and in brainstorming sessions. We refuse the fast fashion, we refuse the products just for our entertainment. If we have a money, we don't have the right to impact the climate. If we have the money and we want to purchase a thing, then we must increase the plantation to reduce the impact of climate change. For example, if we are purchasing anything from the market, it has a carbon footprint of that material in its manufacturing supply chain. And we use the repair things. This is also the sunnah of Hazrat Muhammad sallallahu alaihi wasallam. He wear the torn clothes, and we must not be ashamed to use the repair things in our daily life. We can reuse the things again and again until we can also use the repair material and reuse material. And we can reduce the trash. For example, right now 1.3 billion trash is globally per annum is producing right now, and we can reroute the things, we can revitalize the things. Right, first time approach is only possible with the help of intelligent manufacturing. And we can even use the food waste in the gardening and in the producing of fertilizer as well. This is my textile circular economy project of British Council. This is the completion letter. This is my China exhibition training in August. This is the award from the President of Pakistan that I received in March. Thank you very much.
Thank you so much, sir, for such an insightful lecture. It seems like we have some questions. The person who raised the hand, kindly unmute your mic and you can ask the question. It seems like he's not here. Sir, I want to ask that I totally agree that since I am currently living in Shanghai, so I agree that they work a lot on air quality, trash management, and no carbon emission. While in Pakistan, our work is only limited to labs. We don't practice it on industrial level. So, as a researcher, what we can do to make it possible on industrial level or large scale?
You can just communicate your knowledge to the industry, like what I am doing, that I invited the Chamber of Commerce in Sialkot, that I want to deliver a lecture that how we can shift on the automation and how we can reduce the carbon footprint in our supply chain. And such type of working is possible even everywhere, that the researchers can communicate to the industries. They can visit, and even HEC and Pakistan Science Foundation, they have the projects which is totally aligned with the SDGs. And if we are working on a research project, we need a collaboration with that. What is the triple helix model, that we need the industry for our projects. And in industry we can work on such type of things, that what industry require, they need profit, they need money. And if being a scientist, it's very easy for us to communicate them that your price will not increase and your carbon footprint will reduce. I don't think so that the industries have any issue on such type of working. You can work on the same. You don't need to tell them that invest money on the environment. You just work on such type of projects that can reduce the carbon footprint without impacting on their economy. They don't want to invest on environment. Nobody is ready to pay for the environment. So this is a challenging, and it's very easy that we can reduce the carbon footprint in industry without investing or without increasing their investment in environment.
All right, it's really a good suggestion for all the researchers out there. Thank you so much again for your precious time and such an insightful lecture.
Thank you.
I want to invite Dr. Adnan, who is director of IM Group of Researchers and always being a great sport for us, for his conclusive remarks.
Assalamu alaikum, dear valued guests, participants, and esteemed team. Is the fourth International Conference on Life and Chemical Sciences with the theme From Lab to Life, Emerging Trends in Biological and Chemical Sciences come to an end. I want to express my sincere gratitude and pride for the success of this event. On behalf of the organizing committee, I want to thank our guest speakers, participants, and especially the dedicated team that worked hard to make this conference happen. Our goal focused on providing valuable education and raising awareness through research has come to life through the lively discussion and knowledge sharing during these enlightening days. Organized by the IM group of researchers, this conference provided a common ground for the students, researchers, scientists, and professors in life sciences and chemical sciences to share insights, experiences, and the latest advancement in their fields. The objective we set for this conference were not just met but surpassed thanks to active involvement of everyone present. We successfully encouraged collaboration between experts in biological sciences and chemistry, opening doors to innovative solutions for global challenges, discussions on healthcare, drug discovery, sustainable practices, and the exploration of chemistry, of nature, and biomolecular sciences have undoubtedly advanced scientific understanding, paving the way for future breakthroughs. I want to express my appreciation for the commitment shown by participants in promoting ethical chemical research, environmental awareness, and safety measures. This conference has not only been a platform for an intellectual exchange, but also a catalyst for building a community of responsible researchers dedicated to making positive impact on society. Uh, Special thanks to our distinguished guest speakers whose expertise enriched the conference and to every participant who actively contributed to to the discussion. My gratitude also goes to the organizing team whose careful planning and ensure the smooth flow of events. I am confident that the knowledge shared and connection made during this conference will go beyond these walls and make a lasting impact on the laboratories, classrooms, and research institutions represented here. As we part ways, let's carry forward the spirit of collaboration, innovation, and ethical responsibility that defined the fourth International Conference on Life in Chemical Sciences. Thank you all for your unwavering support, and I look forward to future endeavors that continue to push the boundaries of scientific exploration and social impact. Thank you all.